for our lesson. They were talking about our recursive sorting algorithm. So remember last class, we talked about binary search, which is a way more efficient algorithm than linear search for finding something within an array. But in order for binary search to work correctly, the collection, the array list, whatever we're looking through, needs to be in order. So we've learned two different sorting algorithms up until this point, insertion sort and selection sort. However, neither of those is very efficient. So combining them with binary search doesn't give us any efficiency savings over just doing linear search. So today, we're going to cover a sorting algorithm that uses recursion and is way more efficient than the other sorting algorithms. It's called merge sort. So the way that merge sort works is it divides a list into parts, and then after they're all separated, it merges them back together in the correct order, in numerical order. So we've got two methods that are going to be in part of our merge sort. One part that is going to do the splitting recursively, and the other part is going to be stitching the lists together so that they are in order. So here's a visualization of what merge sort looks like. I have this list. Clearly, it's unsorted 4, 2, 9, 1, 8, 7, 3, 5. Not a sorted list. So we're going to split this into two halves, left and right. And we're going to operate on our left half first. So this list is still not one element long, so we're going to split it in half. And we're going to once again move on our work with our left half. Still not one element long, so we're going to split it in half. Now we have two single element lists, 4 and 2. We can merge those together, put them in the correct order. 9 is up here. Our correct order is 2, 4. Now we can't move any further down in this branch. There's nothing else for us to merge with. So we're going to jump back up to here, where we have the 9, 1 list. 9, 1 is not one element long, so we split that. And then we can merge those single elements together into a 1, 9 list. And then we can merge those into 1, 2, 4, 9. So now this little list is sorted, but we can't merge anything further here. So we're going to jump to the right half. We're going to split on the left. We're going to split, merge those together, jump back up, split, merge, merge, and then we can merge those two halves together so that we have our fully sorted list now. 1, 2, 3, 4, 5, 6, 7, or there's no 6, 1, 2, 3, 4, 5, 7, 8, 9. So that is how we do that splitting in merge sort, split, and we bring it back together. So some information about merge sort before I talk about implementation. Merge sort algorithm is generally going to be more efficient than insertion or selection sort. A very big benefit of this algorithm is that it does not care how the original, how it was originally sorted. The efficiency of merge sort is constant depending on the size of the collection, whether the original array was completely random or already sorted. It'll have the exact same efficiency in both scenarios. Now, it's definitely more complex than either of those two other sorting algorithms. It's going to require recursion in order to work correctly. So, like I mentioned earlier, there are two methods that go into building merge sort. The first method is the one that is recursively going to split our array into those single element arrays. So our merge sort method is going to get an array as a parameter. That's the array that we want to sort. So our first step, remember, anytime we do recursion, we need to have a safe space. We need a way to stop our recursion. Since this merge sort method is going to be recursively splitting our array in half over and over again, our base case is going to be when there's only one element. I can't split a one element array anymore, so we're just going to return that one element array when we have it. Because we're going to return the fully sorted array when we're done. So a one element array is obviously sorted within itself. You can't sort it any more than it already is if it's only one element long. Next, we need to prepare our array, my array, to get split in half. We're going to determine the midpoint by finding half of the length. And then we're going to make two new arrays to represent the left and right sides of that split. So let's say I have an array with 1, 2, 3, 4, 5, 6, 7 elements in it. My length is going to be 7. 7 divided by 2, we want to do an integer division here. 7 over 2 is going to give us 3. So our left array is going to be 3 elements long, and our right array is going to be 7 minus 3, which is 4 elements long. So left and right, they're not the same size, but that's okay. They don't have to be the same size. Now, remember, anytime we create an array like this, it's going to be filled with zeros. It's not going to have any value inside of it. Then, after we have created those arrays, we're going to fill them with the appropriate halves. So our left array is going to get the elements from my array from 0 up until my midpoint. My right array is going to get elements from my array from midpoint up until the end. So we're going to loop mid number of times for our left array. We're going to loop length minus mid number of times for our right array, because that's how long each of those is. And we're going to add elements to left and right from our original array. So we've got 4, 2, 4. Oh, wow, I can't read numbers. 4, 2, 5 in left and 1, 3, 7, 6 in right. So we've got our left and right now. And here is where our recursion is going to come in. We're going to call merge sort on left and right to split them down further, so that they are going to become those single element lists. So first we're going to call merge sort on left. So I'm going to kind of put this in a box to show this is one call. I'm going to have another box for my next call. So my next call, my array, is what I have in left, 4, 2, 5. So my array, 4, 2, 5. Mid is going to be 3 over 2 is 1. So our left array is going to be 1 element. Our right array is going to be 2 elements. And left is going to have 4. Right is going to have 2 and 5 in it. So we've split our array. And then we're going to call merge sort on left again. So my array here is just that array with the number 4 in it. Now, our base case, length equals 1, is true. So we're going to return that array and say left equals that single element array. And then our right, we're going to call merge sort again on the right array this time. So my array is 2, 5. Left is 2, right is 5. And then when I call merge sort on left, they're going to get that 1 element array. When I call merge sort on right, we're going to get that 1 element array. So the last step is going to involve actually merging our left and right halves together into one array again. So we need a second method to accomplish this. We're going to talk about the merge method next. This method takes 2 arrays and it will return 1 array with all of their elements merged together. And during that merging, this method is going to make sure that all of the elements are going to get put into that merged array in the right order. So it's going to pick from left and right in order so that our merged array has things in the correct order. So we're keeping track of 3 numbers here. The current index within our left array, current index within our right array, and we're going to keep track of the current index in a new array called merged. That merged array is going to be a new int array with the length of the combined left and right. So left is equal as 1 length, right is 1 length, so merged is going to be 2 lengths. Then we're going to loop for as long as both my left index and my right index are in bounds. And what we're going to do inside the loop is check which value is smaller. Is left at left index or is right at right index smaller? We're going to add the appropriate value to our merged list. So in this example, left at index 0 is smaller than right at index 0. So we're going to copy from left index at index 0, or left at index 0 to merged at index 0. And something we can actually do is we can do a plus plus inside of those square brackets, and it's going to perform the calculation with the current values, and then it's going to increment both. So mostly I'm doing this so that I have enough space on my slide, but this totally works in our code. We can say m index plus plus, l index plus plus, and it will operate using their previous value and then increment both after the assignment has happened. So now my left index is 1, my right index is still 0, my merged index is 1. So my condition for my while loop, as long as my left index is less than left.length, that is now false. So how are we going to get the remaining values from our other array? Well, we're going to use a couple of for loops to access, to grab any missing values from the array that we didn't finish. So the loops are going to look almost identical. We're going to have for, and then I'm going to leave that first section blank. For nothing, because we're going to use those left index and right index variables in my for loop. So I don't need to initialize anything. And we're going to loop as long as left index is less than left.length. We're going to increase left index each time. And we're going to say merged at merged index plus plus equals left at left index. Now, since my left index is already equal to my left.length, that loop is going to get skipped. We're not going to do anything with it. So we're just going to skip it and call this loop. Exact same loop, except it cares about right instead of left. So for every unclaimed value out of the right array, we're going to add it to our merged array. Because we know that the right array is already sorted. At least right now, they're one element long. But since we are calling back in the merge sort method, left and right are both equal to the merge sort, and that's going to return a sorted array. So we know both left and right are going to be sorted. So once we are done with one of the arrays, we can just grab all of the values from the other array because we know that those are already in order. And then we can return that merged list now that it's all put together and sorted. So from back in merge sort, we're going to return that array that we got to 5 from our merge method. So we return to 5. We're going to update that right array to equal merge sort of right. So that returned to 5. And then we can merge our left and right together. So left and right and middle all start at 0. We see that the right index at 0, 2 is smaller than 4, so we'll copy that 2 over, increase right index and middle index. 4 is less than 5, so we copy that 4 in, and now our left index is out of bounds, so we will copy all of the values out of the right list into our merged list and return it. So now that we have finished that, we can return that merged array 2, 4, 5. So now we're back in our top level. We have left. Left is equal to 2, 4, 5. And that's a different order than it was before. It was 4, 2, 5 before. And then the process is going to repeat for the right half. My array is 1, 3, 7, 6. We fill in left and right. we merge sort left. We split that into single elements. Both of those are going to call merge sort. They'll return because they're one element long, and then we'll merge them. We'll get 1, 3. Left is equal to 1, 3. Then we call merge sort on right. My array is 7, 6. Left is 7, right is 6. We merge those together into the other direction, 6, 7. So now right is 6, 7, and we can merge left and right together. And that will give us 1, 3, 6, 7. So now right is equal to 1, 3, 6, 7. Left is 2, 4, 5. So each of those is individually sorted. So we can now merge those two together. We're going to look at what merge looks like again so that we can have that idea. When we merge two large arrays together. So my left index, right index, middle index, still all 0. And we make our merged array full of zeros. Currently, we're looking at the start index for all of them. Now, which is smaller, right or left? 1 or 2 smaller? 1 is smaller. So we're going to grab the value out of right, increment our right index, increment our merged index. Now, the value in left is smaller. 2 is less than 3. So we will copy that down. 2 goes here, and we increment our left index, increment our merged index. 3 is less than 4, so we'll copy the 3 in. 4 is less than 6. 5 is less than 6. So now our left index is out of bounds, so we'll stop this loop. Our left index is out of bounds again. We're not going to grab values out of the left index, so we're going to call we're going to use our second for loop. Grab any values out of right that didn't get grabbed. We'll add that 6 and 7 to the end of the list. And you can return that 1, 2, 3, 4, 5, 6, 7. And since that's the value we returned from merge, we're going to return whatever that returned from merge sort. And that's our final step. We can return that fully sorted list. That make sense? A lot of steps.
I don't know why, but this seems slightly more complicated than like insertion sort.
Just a little bit more complicated, yeah.
Just a bit.
So, recap of merge sort. Merge sort is a recursive sorting algorithm that can be used to sort elements in an array or an array list. Now, they're very efficient, but it can be, like we just said, somewhat complex to code. It's more complex than doing swaps within a single array. Lots of splitting, lots of merging together. Questions on how merge sort works? Cool. And I will stop our recording.